Okay, welcome back, guys. I'm glad that we struggled together. We've been on this journey together. I'm really grateful for y'all watching my video, and get finally we can find alpha is sine square of theta, and now we can find the rest of the function, and then we substitute back into the original differential equation, and then we solve it. Okay, so this first the first British flag circle, British flag, you will have which one I'm gonna use, the first one. Okay, this one. Oh, I want to use one, so okay, I'm gonna find chi. Okay, so what do you have? You have alpha times chi equal 1, right? So what chi equal to? Chi will equal to 1 over sine squared theta. Okay, the second British circle, I call it British circle because it's a British flag but in the circle. You see what I'm saying? You have beta, let me check it again. I just want to make sure. Beta equal, where's the British? Okay. Yeah, this, oh my god. No, that's not this beta. Beta. Cotangent theta times alpha minus alpha prime. Okay. Cotangent theta times alpha minus alpha prime equal to alpha is sine squared, so cotangent theta times sine squared theta minus derivative of alpha is obviously this 2 chain rule, 2 sine theta cos theta, so beta would be equal to cotangent is cos sine times sine square minus 2 sine theta cos theta, right? Beta will be equal to what? Beta will equal to cos theta times sine theta minus 2 sine theta cos theta will be equal to negative cos theta sine theta. All right. So we have two results. Now we have chi. Let me color it like color me run, And we have alpha. And we have beta. Remember the original ANZAC we have the goal, remember? The goal is we transfer this differential equation. We transfer this. Yeah, the goal is we transfer this to g times, let me see. I have to, yeah, I have to keep on, watching back. Okay, chi times alpha f. Okay, alpha f. Okay. So the goal is we sorry for g times alpha f plus beta f prime, right? So now we have everything. So we can proudly say, and now we have, what is chi? Our chi is 1 over sine theta square times alpha. Alpha in this case, what's our alpha? Sine theta square. Yes, exactly. Times f plus what's our beta? Negative cos theta negative cos theta sine theta times f prime equal 0. Okay, now we're gonna solve the differential equation. We have already converted to something simpler. You see, now it's just first order. So I'm gonna go ahead and times both sides by sine square. So this sine square will cancel out. This derivative remain intact. We didn't touch it yet. Okay. And 0 times sine square is also 0. And now this is the most important part. Now remember, y'all remember that in the previous video I told you, like, I only want to find alpha. I don't want to find a solution of alpha. I don't want to find a club of alpha, or an organization of alpha. Oh my god. And anyway, guys, get involved. Like on campus, I understand you're busy, but like spend like 1 week, 1 day per week for club. I'm trying to do that right now. You meet people, and you meet people who care for you, who don't, play around, you know, like don't play like Singaporean slang, but yeah, join organization, get involved. It's not bad. People there support you. If you shy, it's okay. No one there to kill you. Everyone there to uplift you, you know, try to make you a better person. Anyway, how are we gonna solve that? Now you say f prime times cosine. Okay, sorry. So I'm gonna solve this is an EMAT problem. So you have sine square whatever inside the derivative equals C1. Okay. I'm gonna rearrange it a bit. Okay. I'm gonna do the minus sign both sides. Okay, guys, notice this. Negative C1 is the same C1. Why? Because C1 is a number. Negative C1 is a number. You want to represent it in the most simple way. You don't want any negative sign, okay? It all point to one thing, a damn number, okay? So you want to represent it in the most simplest way. So I'm gonna, instead of getting negative C1, we just write C1, okay? So what I'm gonna do, I'm gonna divide both sides by cosine theta. So we have this. Right? Okay. So you have f plus negative sine square over cos theta sin theta times f equal C1 over cos theta sin theta. Okay? So you have f prime plus negative sine theta over cos theta times f equal C1 over cos theta times sine theta. Now, how are you going to solve this? First order. This is the first order differential equation. Well, you guys can go ahead and, you know, look up the formula for this, I guess. In my engineering math series, I would tell you the motivation behind this. But now I'm just going to go ahead and plug in the formula, you know. So, you know, I'm sorry to anyone who expect like an answer or a proof right now. I would go ahead and plug in the formula, okay, to solve this problem. So now what you want to do, you should take, if you UH student, okay, you should take a class called engineering math, right? My year, math 3321, my year, well, whatever, this YouTube is open, I think this is 2021. The code is math 3321, so go ahead and take that class. You gotta learn how to solve it. So f prime times e to the power, I'm gonna time this side, okay? D theta, okay? Sorry, kind of convoluting. Okay, now it makes more sense. Plus, you know, times negative sine theta over cos theta phi equal C1 over cos theta sin theta time e to negative square of this. Okay, I'm gonna go ahead and evaluate this guy. Okay, so I'm gonna call that I1. So I'm gonna call it I2. Okay, I2 go to e the power of negative sine theta over cos theta d phi. It will be equal to e. I'm gonna put the negative sign outside. Sin theta over cos theta phi. What is equal to? It will equal to e to the power of negative, you know, ln cos theta negative sign right here, because, well, what you can check it out yourself. You can do like u equal cos theta yada yada yada. and then you du. You can check it out yourself, okay? And I'm not gonna plus c either because this is the former telling. Like, I'm not gonna add any plus c because I just want to find one function. I don't want to find a family of function, okay? So I just want to find one function to create to simplify into a single derivative. So yeah, you see I didn't write plus c here, so it would be equal to it would be equal to e to the power ln cos theta equal to cos theta. Right? You agree? Okay. Beautiful, beautiful, beautiful. What's the thing we're gonna do next? Oh, okay. So now I'm gonna replace it. I'm gonna plug it in. So f prime times cos theta plus negative sine theta times cos theta times cos theta times, oh, I forgot f here. I always forget f here. Times f, oh, okay, equals c1 over sine theta cos theta times cos theta. Okay, so you have this is f prime times cos theta plus negative sine theta times f equals c1 over sine theta. So what's this? This is f times cos theta prime. You can verify it yourself. I already verified for y'all in the last video. But if you have any question, drop it in the comment. Okay, equals c1 over sine theta. Almost there, guys. Almost there. I promise. So now you have to find c2, right? So how you ever, and then you integrate both sides, right? It's the theta. So you have f times cos theta equal this. Alright, and now how you calculate this integral? Well, you can say this is E3, I3, okay, equal, let me help you guys to calculate this integral. Yeah, you would say this is, you put C1 outside. And then, let me think. Okay, you're gonna times sine theta here, sine theta here, sine theta square, dphi equal to, you have to convert to something cos. Okay, so sine theta phi over 1 minus cos theta square, right? Okay, now I'm gonna evaluate this. Okay, so say this is I4. Okay, I'm gonna evaluate I4, so I'm gonna do some substitution. I'm gonna say v equal to cos theta, so dv equal to sine, negative sine theta d theta, right? So I'm gonna substitute in, so I4, my I4 will be equal to c1 times negative dv over 1 minus v squared, right? Because okay, so it would be equal to c1 times integral dv over 1 minus, oh, v squared minus 1. Oh, actually, I think I'm not gonna put the sign. I'm gonna put negative sign right here. dv over 1 minus v squared. Okay, does it make sense, guys? Does it make sense? I put this negative sign outside. Okay, I put this negative sign outside. Okay, come to this point. So it will equal to what? It will equal to negative c1 times, I'll show you how to, you can do partial decomposition, I think, but I'll teach you a way, a very interesting way. So first you factor this, factor the denominator, okay, and dv, you put it here, and this is 1, right? So 1, you have to convert to something useful. So you agree with me? Because 1 minus v plus 1 plus v is 2. 2 over 2 is 1. 1 times dv is dv, so it's still dv. You see what I'm saying? This is called a magic. Some people call it magic. I'd say like this is practice, and you get used to it. You're gonna love it. Like it's sometimes faster in partial decomposition, way faster. But partial decomposition is more generalized. So what will work best for you, And I'm gonna put 1 over 2 over outside like this, and then inside I'm gonna write like this. Okay. V plus 1 plus v plus v 1 plus v and that dv. So if we equal to say negative c1 over 2, what's this? This is integral of 1 over 1 plus v plus 1 over 1 minus v dv. It will be equal to negative say 1 over 2 times ln 1 plus v minus ln 1 minus v. Why you ask me minus? Because when you do the derivative of ln 1 minus v, it will be 1 over 1 minus v times negative 1, right? Because the derivative of 1 minus v is 0 minus 1 is negative 1. Therefore, you have to add a negative sign to correct for the mistake, okay? To correct that mistake. So now you have to plus c2. Yes, that's where plus c2 come in. So if I do some, remember guys, never forget your logarithmic rule, okay? Never forget your logarithmic rule. Like always remember your logarithmic rule. Like never forget it, honestly. Like so what are we equal to? It will be equal to negative c1 over 2 ln 1 plus v 1 minus v minus c1 over 2 c2. Okay, now I'm gonna let v equal cos theta. Okay, I'm gonna let v equal cos theta. So I'm gonna return it to the original form, like a demon, like a evil human become the demon again after a while. Like he had to return to the form. Like if you watch Captain Marvel, so 1 plus cos theta over 1 minus cos theta minus c1 c2 over 2. Okay, so what this equal to? All this we evaluating is I4. Okay, I4 and I4, let me see. Yeah, I4 is I3. Actually, I realized that I write I3 and I4 the same way. Okay, so we have f cos theta equal to all of that. So because f cos theta equal to I3 and I3 equal to I4 and I4 equal to this right here, and then yeah, now you're gonna have this. And I didn't realize that I write I write I3 and I4 the same way. So okay, you divide cos theta by both sides. This should be your result, and you can verify it yourself. Yeah, this should be your result. Like if you want to make it cleaner, I guess, like I think you can clean it up. I think you can like definitely clean it up. Like I think you can clean it up. I'm not sure, okay? I think you can clean it up by replacing this and this. So negative c1 is still a number, right? It's a number. So you can write like c1, negative c1, c2 is also a number, but a different number than negative c1. So you write c2, I'm not sure. You're not sure, you can keep this, but if you want to reduce it further, it would be C1 over cos theta ln 1 plus cos theta over 1 minus cos theta plus C2 over cos theta. Okay, this is the final result we have. And oh, I mean, yeah, negative. Sorry. Yeah, 2 is correct. This 2 is correct. I just want to highlight it too. So when you replace this, you replace the whole thing. Okay, because it's a number again. Negative C1 C2 over 2 is it's just a number, and negative C1 over 2 is a number. So you can write it in a cleaner way. You see what I'm saying? Because C1 denote a number, a random number. Negative C1 over 2 denote a number. So why would you write negative C1 over 2? You just write C1, which is more simpler. You know, there's no negative side, there's no over 2, right? But yeah, this is the one. And you can depend on fluid mechanics. Usually they have the boundary condition. So, sorry, scroll it. Let me actually do this. Okay. This is the final result. Like, if you like, usually fluid mechanics, they have the boundary layers, the boundary condition. Like, you look at it and you find C1 and C2 for yourself. But this is F. Okay. So I thank you so much for your attention. This is a long series. We're not done yet though. I'm gonna make a series when I talk where I talk about like how Dr. Mehmet Terrace may come up with the guest. This is just my opinion, but it can be wrong. It can be right, you know, or it can be wrong. But I'm going to go ahead and do that. That will conclude the fluid mechanics series, that differential equation series. And yeah, I'll see you in the next video. Thank you so much.